Uh, Welcome back. So in the previous topics we were discussing about the shear force and the bending moments, then the what are the types of stresses will be developed. Now we'll see about the mainly come to the deflection. So when the deflection comes into the picture, when some of the external loads nothing but when we're going to apply the load. For example, if you take in a beam, because mainly we have concentrated or we have discussed about the beams only. So mainly what happens when we coming to when we discuss about the beam, some external loads, that is external load is nothing but which is a load or a roof which is acting on the beams. So the beams has to withstand the load. That is the reason we are going to use this in a beams. So under external loads, the beam is subjected to stresses and deformation at various points along the length. Yes. So the deformation or the deflection. Deflection is nothing but where the bending moment when we calculate the shear force and the bending moment when we problems. So the deflection is nothing but which forms in the form of bending moment curve. So what happens when the external loads on any beams? So the beam is subjected to stresses. So stresses will be developed. So whether it might be in a compressive stress or whether it might be in a tensile stress. So the stresses will be developed based on the cross-sectional area. Cross-sectional area is nothing but whether the entire length of the beam or at some various points along with that length also. So the entire external load will takes place along with this. So this deformation is caused due to the bending moment and the shear force. Shear force is nothing but exactly where the forces is acting, and the bending moment is nothing but along with the force into the distance. So this is caused the shear force and the bending moment. So under the action of external loads, the beam is subjected to stresses and deformation at various points along the length. The deformation is caused due to bending moment and the shear force. Since the deformation caused due to stress shear force in hollow beams is very small, it is generally neglected. See what happens when the deflection occurs in the hollow beams, that is mainly we are going to neglect some very small, it will be in the neglect, we can able to neglect. But what happens, why the deflection of the beam occurs is because of the external loads, and the stresses and the deformation will be also be developed along with this external load, that is when we're going to apply the load on the beams. Now next we're going to see about the elastic line. What do you mean by elastic? Generally when we see the material for the, generally when you take the stress strain curve for any material, we call it as a plastic state, like elastic state. Elastic state is nothing but where the material can able to regain its shape and size after the removal of load. That is what we call it as an elastic point. But what happens in the similarly in the elastic line is nothing but it is a line which represents the deformed shape of the beam. It is the it is a line which represents the deformed shape of the beam. Hence, it is the line along with the longitudinal axis of the beam where it goes to bends. So here also the deformed shape. The deformed shape is nothing but where when you going to apply the load, the because the deflection takes place. So the deflection takes place or the deflection comes in the form of curve. So similarly here also the elastic line, how we can able to measure or how we can able to represent the elastic line is nothing but it is a line which represents the deformed shape of the beam, and hence it is the line along with the longitudinal axis of the beam where it going to bends. So this is how we are going to identify the elastic line. So the next one is about the deflection. So the vertical displacement measured from original, that is from original neutral surface to the neutral surface of the deformed. See the deflection, how we can able to identify, how we can able to measure the deflection is nothing but where we can able to initially we are going to measure the original neutral surface, that is from the neutral axis. Then we are going to measure after the applying the load what is the deflection or the deformation takes place. So from the neutral surface to the neutral, is from the neutral layer to the deformed shape, we are going to measure that. So that is what we call, how we going to identify or how we can able to find out the deflection in the beams. So next we're going to find out the slope. So this is very important in order to identify the slope. See the slope will vary from one point to the other point, that is from one point of load to the other point. For example, the slope will form in the constant when it comes to the shear force. So that is when it will be in the point load. So it will be the linear, the slope will be linear when it comes to the bending moment. Similarly when it comes to the UDL, that is it forms to the a linear, and then it will form the parabolic. So similarly, when come to the UVL, so the bending moment will be the parabolic, and the shear force will be the parabolic, and the bending moment will become a cubic. So like this, the slope will vary according to the type of load is which is acting on the beams. So based on that only we can able to identify the slope. The slope is nothing but angle made by the tangent to the elastic curve with respect to horizontal. See the angle made by the tangent to the elastic curve with respect to the horizontal. So the designers or the engineers have to decide the dimension of the beam not on the based on the strength requirement, but based also we need to consider on the deflection also. See, when we are going to the designers, when we are going to calculate, they should not calculate based on only the so even they should consider the deflection. In a mechanical component, the excessive deflection causes misalignment. For example, if you take in a mechanical component, when we assemble or when we put together the two, combining the two parts, the deflection causes the misalignment, means it cannot able to perform exactly, so that will cause a non-performance of the machine. That is when we consider the misalignment when in the mechanical. But when it comes to the building or structures, it gives an psychological unrest, and sometimes cracks in the roofing materials. So this causes the deflection calculations are required to impose the conditions in the analysis of the intermediate structures. So this also causes the intermediate structures when we compare to the slope. So the next one is about the strength. So it is a measure of the resistance offered by the beam to the load. See the beam, what is the capacity of the beam and how much the load can able to withstand the beam. That is also, yeah, that only gives the what is the strength of the beam or how much load it can able to withstand. And the next one is about the stiffness. So stiffness is nothing but it is a measure at the resistance offered by the beam to deformation. Usually the span or a deflection used to denote the stiffness. So the stiffness is nothing but what we call, that is in the term of beam we call it as a flexural rigidity, and it is to denote the stiffness. So that is nothing but stiffness is nothing but the resistance offered by the beam under the deformation. So whenever the deformation takes place, what is the resistance is getting, so that gives the stiffness. So where it can we can able to measure the resistance, or what we call it as a flexural rigidity. So this is how we can able to see the measure the slope, stiffness, strength, and in a deflection or an elastic in the deflection of the beams. So these are all the things that we where you can able to identify the based on by using the deflection of beams. These are all the things where we can able to identify.